Hey guys, John Britt here. Hey, I'm going to do a video for you here on rocks and minerals. And the way this came about was I'm getting packed up for this workshop I'm going to have in Stroudsburg, PA at Kettle Creek Pottery this weekend, July 18th to 20th, 2025. In case you're looking at this 5 years from now, it's over. But what I was doing, I saw my minerals. I have a small collection just for pottery stuff, and I thought I'd never videoed this, so I thought I would do it as a part of my basic glaze chemistry free online class on YouTube. This video will be video number 40, and so I'm going to try to do this. I'm going to mix it up a little bit with, I've got a lot of books, and I know that people don't read many books, but the books are pretty good in terms of helping you to gain a knowledge of things. It's not, there has to be a lot of them. So it's not like the internet where you just Google something, but it's like a finite resource. So it actually, in some senses, is pretty good because, you know, when you go online and it's just endless. And so it gets kind of confusing and you're never sure which to believe, but these books are really good and they can help focus you. So I'm going to show you those, and then I'll show you the samples. I'll try to go kind of slow because you kind of got to look at these a little bit. So let's see. So that's the course that's happening. Here's what we're doing. Number 40, rocks and minerals. So let me see if I can put this down a little. Okay. So here's what I've got here. I've tried to organize this a little for you. I've got, feldspars here, various types. And then I've got silica and chert. And I'm also showing you some samples I've collected in bottles so I can make pottery out of it. I just have 40 mesh silica. I'll just grab that container. Anyway, these are some good books. And this will be Kaolin. There's a great book on, there's also a good book, I don't think I brought it out here. It's called Wild Clay. And then, those are manganese nodules from the bottom of the Atlantic Ocean, which are pretty cool. So I've just got all these things. I'm going to just show you this like this. And then I'll go through a few of them. Here's a great book. It's called The Potter's Dictionary by Frank and Janet Hamer. It's a 5th edition, super good. Really great for potters. So that's just like an overview of stuff. All right, so let me now, I'll just start with this feldspar. So here's a great sample of feldspar. See this way it's cleaved? It's it's like this and like that. It's so that's classic feldspar. And here's another one. So I'm pretty sure this is a potassium feldspar. Here is a sodium feldspar from down the road. So this is from the mine by us. It's I'm not sure. Actually, I'm not sure what it's called anymore. I think it's Sibelco. Used to be there's Zemex, and it used to be KT Feldspar. It just changes the name all the time. Anyway, so I went over there and got some samples from them. And the other thing that I'll do, well, one thing I want to show you here is how, see that there's mica associated with that. So all in here is mica. And then there's probably quartz in there too. So we'll talk about that in a minute. There's some mica, and that's how it ends up coming down this line to silica and quartz. But what I'll often do is that when I'm on the road in my car, I have these books, Roadside Guide to Geology. This is Colorado, Tennessee, a whole bunch of these books. They're really good because then you can pull off on a road cut and you can, maybe find this rock there. See, there's silica there. And then what I do is I bisfire that, kind of grind it up, and then I'll put it into containers. I'll show you here. Like this will be a local Feldspar that I got unprocessed. So I'll just have that on my shelf. And then it's ground up. And then what I can do is run that through a sieve. And then I'm going to get different, mesh sizes. So that's pea gravel. This is through a hardware cloth, and that's finer and finer, etc. And then that way, anytime you want to try something, you can either put it in clay body or in a glaze. All right. Well, let's do this. See this mica is very similar to feldspar in composition. It's got other impurities, but it's very, you can just break that. So the crystal structure is different. This is very hard, and this can be split apart. But that's what they'll do when they process feldspars. They'll grind it up, float off the feldspar. It's called flotation processing, and then they'll sell it to you. They'll grind it up. They'll soak it in hydrofluoric acid and take out some silica, and then they'll put it through a magnetic separator, and then they'll sell it to you as G200 or something. All right, and this is dental feldspar. This is, I forgot where I got this, but purportedly it's just very high potassium feldspar. You don't really buy this, but there's just many types of feldspar too. And then I've got here spodumene. So this is a sample of spodumene, a lithium feldspar. I tried to write this stuff a little bit for you. What you can do is get this book, get this Frank and Janet Hamer's book, and just look up then spodumene and see what it says, and then you try to remember all that stuff. So this is potassium. Now, when you get feldspar, it's not just potassium. This is an idealized formula. There'll be potassium and sodium and magnesium, all kinds of impurities in there, but it's dominated by potassium. All right, and then there's amblygenite. This is, you can see that structure, that planar structure there. And this is lithium and alumina and phosphate in there. So it's a very interesting material. I'm not sure if you can get that anymore, but that was a cool material. Then a lot of them will have other impurities in them. This is rose muscovite here. So they have impurities of chrome and manganese, iron, etc. All right, so then what do we have here? Then we're into silica. So silica is fantastic material. It's the second most abundant next to oxygen. Here's a crystal. So that's very nice. And then these will be other forms, like I think I got this in Arkansas. And then, so that's, well, here's some jasper and chert. These are forms of silica with impurities in them. So they might have iron, they might have chrome, they might have manganese or copper, and or then like this one. And so what's interesting about this one is there's the chert in there, jasper, and then around it is calcium carbonate. So in the old days when they said they were putting flint in, flint meant it had like 5% calcium in the silica. Nowadays we just use flint, quartz, and silica all sort of interchangeably. This is called, I'm not really too sure what, I'm just an amateur geologist, but this is angle plated, I spelled that wrong, angle plated quartz. That's just another form. There's so many forms of all these things. All right, so say for instance then what you might do, I'll tell you what, we'll do this, we'll open this up. See if we can find, like, so say I was to look at quartz then. You know, it's going to give me all this stuff about quartz, explain it. And so then here's a nice little chart showing you types of quartz, rose quartz, and then the stones, you get sand, sandstone, quartzite, and then over here is the jasper and chert and stuff. But anyway, they got a crystal too, and then they'll show you other ways to, you know, imagine what's happening. So that's very good. So then we'll do the clay. So there's also very good books on clay. This is a great one by Susan Staubach. That's very readable. This is Mimi Obstler. This is Out of the Earth into the Fire. It's a great book too. It talks a lot about, like, they really go into, or she really goes into depth on clay and kaolin. Like, she'll talk about, here's all the kaolin analysis. She'll go through all that. But then here is a sample of, I got this in Arkansas, kaolin. Like they were telling me that they used it in kaopectate. So that was kind of interesting. And this is kind of pink, so it's got impurities. Another good book. All right, let's see what we got over here. Oh, this is a good one. This is silicon. Now, silicon is, it's not silica, like SiO2, it's Si. And so this is the metal silica. And what they do is they take sand and coke, which is, you know, carbon, and they burn it in there together. And then it takes all the oxygen out. And then you get this metal. And they cook it at about 2,700 Fahrenheit. And then, so then they make stuff from that, like silicon carbide, or they, then what this is used for, because this is the age of silica, what this is used for is making silicon chips for phones and transistors and, you know, computer chips and stuff. So then what they're doing, but this doesn't conduct electricity. So when they add things to it, like trace elements of things, it'll become a semiconductor. And so then that's how they're able to control it. So that's a very cool thing. What else we got? Oh, I love this. This is called tourmaline. This is the cocktail of minerals, and the way this is interesting now, like I said, I'm just an amateur geologist, but my understanding of this is that when you have feldspar, first you're going to have granite, which is even more complex, and then it's going to erode to feldspar, which will then erode to kaolin. And what happens is, the way you get iron-free kaolins is, this will be in a batholith, and then all of a sudden, as it's cooling over millions of years, tourmaline will form and pull out all these impurities, like manganese, iron, calcium, magnesium, I mean, all these things. And then it'll form this crystal, and then you're left with silicon, alumina, and you get an iron-free kaolin. All right, here's another rock that I love. This is basalt, and it was sitting in, so basalt's coming out of a volcano, and it's flowing, and then as it sits there for a while, it's quick cooling compared to being under the ground, but it's slow cooling enough to sometimes form olivine crystals like this. So then you get a sample like this where things are starting to crystallize. And then olivine will have like iron impurities in there. So that's very cool. This one is obsidian. So this is volcanic glass, very sharp here. And you see that conchoidal fracture there. And what this is the magma comes out and it cools very fast. And it doesn't have time to form a crystal structure. So it's a glass, it's amorphous. And so that what people did was they make arrowheads out of this kind of stuff. They chip it, and it has that conchoidal fracture there. You can kind of see there. Now that is going to be very similar to silica, but it does have impurities in it. and other, you know, fluxes and stuff. All right, so then I have these other books, which are just, you get all kinds of great stuff in all, you know, this is going to be more focusing on, you know, rocks and minerals and finding samples of things, but it's still interesting. I've used this one a lot because I used to live in Ohio. Let's see, oh, this is a cool one. This is galena, so that they used to like dust galena onto pots. So this is lead sulfide galena. It actually looks a lot like this silicon, kind of, but this is more got a square kind of crystal structure, and it's also kind of similar in structure to this. This is iron pyrite. So I'm sorry, pyrite. It's iron sulfide. This is lead sulfide, but it really makes it cool. And they're very, you know, people say there's never a straight line on nature, but oh my God, that's about as close as you can get. It's very sharp too, these crystals. Crazy. Anyway, so then there's this is a small rutile thing. These, I told you these were manganese nodules, and these were, somebody I knew worked at a university. They were throwing them out, and they got them at the bottom of the ocean, of the Atlantic Ocean, where the two plates come together, and had all these manganese nodules there. All right, here is copper. There's many forms of copper, but that's a nice metallic-y one. But then you get like this is very heavy. If you pick this up, you can see it kind of, you know, oxidizing here. And then there's many other forms that are like got all kinds of, it's not so pure. This might be an ore, copper ore, where they would grind it up and then get it. Or this might have some pyrite in there also. And then this is cobalt sulfate. And then there's tons of forms of iron too. I didn't get any out, but this is limonite, yellow ochre type stuff, and then these are here's specular hematite. That's a type of iron. So that's cool. Trying to see what else we got here that's interesting. Yeah, so then let's say we go to this is like forms of calcium. So this is hydrated calcium sulfate, and I think that's what this is gypsum rose. And then here's optical calcite. It's got that planar structure too. Here's some impurities in there. Anyway, but you can also get calcium from eggshells. So I'll calcine a bunch of eggshells and then grind them up, and I'll get some limestone and I'll grind that up. And this is similar to plaster of Paris, by the way, alabaster. And then, well, here's kyanite. It's a low expansion grog for clay bodies. This beautiful sample here of that. And then, like, well, this is talc. So this is very slippery. You can feel it. It's very slippery. So that's magnesium and silica. Here's barium, barite, crystalline structure. I think it's barium sulfate. Apatite. This is like has phosphorus in it, so it's kind of like bone. Bone ash is tricalcium phosphate. What else we got? Oh, this is a good sample. This is another good book here by Parmalee, if you're really into technical stuff. This is a good one here of Gersley. This is a mineral sample of Gersley. Very beautiful. This is ulixite, some aka TV rock. You kind of see through it. Then they'll describe all this stuff, what it is, and I think I'm coming to the end of my video here. this is a good book, but you have to be really into technical stuff. So not every book is for everyone. So if you can find some of these books that help inform your practice, that's great. And if you could assemble a bunch of minerals like this, is very helpful for you to understand what we're doing with pottery, because we're basically just working with materials and understanding materials. So if you could read all these books by tomorrow and then come back and we'll have a discussion about it. Or you can head to the workshop. I'll try to bring them up there.